Today's lesson is 7.4, Logarithms. And to talk about logarithms, this is probably a term you've maybe never heard before, and it's an advanced math term, and it goes right along with the exponential functions we've been learning about. So let me kind of give a little bit of an explanation of how you can think of a logarithm. We talked in Chapter 6 about inverse functions, how addition is the inverse of subtraction, and subtraction is the inverse of addition. Multiplication is the inverse of division, and vice versa. Division is also the inverse of multiplication. They're inverse operations. If you have x squared, then the square root of x will get rid of it, and vice versa. If you have x cubed, the cube root of x gets rid of it, and vice versa. So how do we get rid of 2 to the x, or 3 to the x, or e to the x? How do we get rid of a number where the variable is in the exponent? Well, the opposite of that is going to be a logarithm. So if I have 2 to the x, its inverse is going to be log base 2 of x, and vice versa. The inverse of log base 2 of x is 2 to the x. So this is a little bit like when you first learn addition, and you learn how to add, and then you learn to multiply, and multiplication is a faster form of addition. And then when you learn how to deal with exponents, you see that that's a faster form of multiplication, is using exponents. Well, the logarithm works right along with exponential functions, and it just undoes what an exponential function does. So let me show you some examples of how this is used, and it might make a little bit more sense as we go. If I have, for example, log base 7 of 49 equals 2, since the logarithm is the inverse of the exponential, I can actually rewrite it. So first I'm going to rewrite this as an exponential function. And to do that, that would be 7 to the second power equals 49. Okay? And so what I'd like for you to see is where each part lines up. The base of 7 turns out to be the base number over here. The 2 that's on the other side of the equals is my exponent. And the 49 is right here. So the 7 moved to here, the 2 moved to here, and the 49 moved to here. And so I always say base equals number. That's what helps me remember the order. So base to the equals number. So 7 to the second power equals 49, and that's true. 7 squared does equal 49. So that's how we rewrite a logarithm to look like an exponential function. Let's try another one. If I rewrite this one, my base here is 4. My equals is the number across my equal sign is -1. And then my number that's left is 1 over 4. And so you may remember 4 to the -1 does equal 1 over 4. So that's how we rewrite a logarithm in the form of an exponential equation. Now, why is that useful? Well, it's useful in a couple of ways, and one of them is when we evaluate. So if I'm trying to evaluate log base 9 of 81, I'm trying to find out what does this equal, I'm going to write it equals x. That just gives me something over here to use for my power. So if I rewrite this, now I have 9 to the x power equals 81. That's what I get when I rewrite it. And then I just have to figure this out. What would the power have to be? 9 to what power equals 81? Well, 9 squared equals 81. So x has to be 2 to make this work. So log base 9 of 81 equals 2. Okay, let's try this one. Log base 8 of 1. What does this equal? So I'm going to say it equals x. I'm going to rewrite it. 8 to the x power equals 1. And this may be a little bit harder for you, but 8 to what power equals 1? Well, we know there's only one exponent that can cause a number to equal 1, and that's 0. 8 to the 0 power would equal 1 because any number to the 0 power always equals 1. So log base 8 of 1 equals 0. Okay, and I've been talking about the inverses, so now we're going to just actually find the inverse. And this is not really too difficult because we're just going to follow our same pattern of rewriting it first. So if I were to rewrite this one, I still have my base number, the equals is y, and then my number is x. That's changing it from logarithm form to exponential form. But for it to become an inverse, I have to actually switch the x and y variables. So I'm going to switch this and be 5 to the x equals y. And that is the inverse to this function. Okay, now we're going to graph this. Log base 3 of x. So we're going to have our x, y table, which we've done in the last two sections. And I'm going to pick some numbers to plug in. One thing that's nice about logarithms are never negative. So, and I can't even take the logarithm of 0. So the lowest number I can use is 1. So I'm going to do 1 and 2 and see how that helps me. 1, 2, and 3. So when x is 1, that would be log base 3 of 1. And we actually have done this before. It's going to be 0 because 3 to the 0 power would equal 1. If I do 2, that would be log base 3 of 2. This one's not going to work out so, oops, not 0. This one's not going to work out so well, so probably I'm going to say that was a bad choice. Let's try 3. Log base 3 of 3 is going to be 1 because 3 to the first power equals 3. So for 3 I have 1. So I'm going to think of another number that would work really well. And if my base number is 3, then we think in terms of multiples of 3. So how about 9? 3 to what power equals 9? That would be 2. So if my x were 9, my y would be 2. Now I don't really have to write all this out. I can actually use my calculator to get these values. And that's probably what I would do, is I'd just use my calculator. But since I'm doing this for you guys, I have to do it by hand and show you how to get those values. So I'm going to make my xy axis. I'm going to plot the point 1, 0. So 1, 0 goes right here. I'm going to plot the point 3, 1. That goes right there. Oops. Right here. And 9, 2 would be way out here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I go up to 2, that's not very far. So, be nice to know how to connect these. What do I do from here? So, obviously I can connect it like this, as I missed that dot, sorry. But remember I said logarithms can never be negative, so it always is going to go down this way. So the logarithmic function is always going to have this basic shape. It looks a lot like an exponential, but it always will come up and go out. Okay, now your assignment is page 114 through 115, 1 through 24 all. That may seem like a lot of problems, but remember a lot of this is just rewriting. And the rewriting is really short and simple. And if you have any questions, please see me in class.